In this video, we will be finding molecular weight and identifying a probable gas. So we have a cylinder container, and that is being filled with nitrogen gas at STP, standard temperature and pressure, and it has a mass of 25.28 grams. This same container is also filled with carbon dioxide at STP and has a mass of 25.44 grams. If filled with an unknown gas at STP, the container mass is 25.04 grams. We want to calculate the molecular weight of the unknown gas and also state its probable identity. So we want to calculate the molecular weight. Now note, each container contains the same number of moles of gas. So let's get started. So the first container has 25.28 grams, right? This container has gas and the container itself. So this will equal the mass of the cylinder plus N gas, the number of moles of gas, times the molecular weight. This is a nitrogen gas. Nitrogen gas, the molecular weight is 28 grams per mole. Next, we'll do the second one. In this one, we're dealing with carbon dioxide. The container contains 25.44 grams. This is equal to the mass of the cylinder, which is the same, plus N gas, the number of moles of gas. We said that each container contains the same number of moles of gas, times the molecular weight for carbon dioxide is 44.01 grams per mole. And now we have two equations and two unknowns. One unknown is the mass of the cylinder. The other unknown is the N gas. And so at this point, I will use my TI Inspire CX cost to determine N gas and mass of the cylinder. So we hit menu, we hit algebra, we hit 7, solve systems of equation, and the first one, solve systems of equations. So we have two unknowns. The first unknown is the mass of the cylinder, and the second unknown is N gas. And so now we write what we have. So 25.28 is equal to the mass of the cylinder plus N gas times 28.02. Second one was 25.44 is equal to the mass of the cylinder plus N gas times 44.01. We simply hit enter, and this is what we get. So the mass of the cylinder is about 25 grams and N gas is about 0.01. So let's write that down. So we know now that N gas is equal to 0.01 mole and that the mass of the cylinder itself is equal to 25 grams. This is very important for the third step. If it is filled with an unknown gas at STP, the container mass is 25.04 grams. So we now know that we have 25.04. This is equal to the mass of the cylinder, which we said was 25 grams, plus N gas. We know N gas is 0.01 moles, times now molecular weight. This is what we want to find. We want to find the molecular weight. So if we subtract 25 here, we would get 0.04 grams is equal to 0.01 moles times molecular weight. Divide by moles, and we would get that the molecular weight is equal to 4 grams per mole. 4 grams per mole molecular weight would correspond to helium on the periodic table. So this is the molecular weight, and this is the probable identity. And that's all we need to do for this problem. And just as a side note, each step said STP. This was STP, this was STP, and this was STP. So we really didn't need to worry about pressure and temperature because all three had the same pressure and temperature. And that's all we need to do for this problem.